We went to this one. We're going to go back through how we found the amplitude. So the amplitude was, yeah, nope. So the amplitude, we did the absolute value of the max. So in this case, it was 10, minus the min, minus negative 10, divided by 2, which was 20 divided by 2, which is 10. So we found the amplitude was 10. We took the period. We always started on the y. In this case, we went from a max to a max, and the period was 4 pi, which was great. But the period didn't get me my b value. To get my b value, I did 2 pi divided by the period, or 360. In this case, it's 2 pi divided by the period. So it would be 2 pi divided by 4 pi, and we came out with a half. The midline, we did max plus min divided by 2, so it was 10 plus negative 10 divided by 2, which was 0. Or, we talked about it, we said if we counted up 10 and we counted down 10, they would meet at the midline. And I told you no matter what, you had to have the midline drawn. We agree? And I said you have to have the midline drawn for the c values of sine. So if you don't have the midline drawn, make sure it's drawn right now, because we need it for our c values of our sine. Now, we did some equations. We did y equals positive cos, so positive 10 cos. And we did y equals negative 10 cos. And we did y equals positive 10 sine. And we did y equals negative 10 sine. And then we put our b value in. Our b value was a half, so we went a half. X, like a half. X, like bracket, bracket, a half. X, bracket, bracket, a half. X, bracket, bracket. And then we put our plus d at the back, which is our midline. So d was 0. So do I have to add plus 0? No. But then we put in our c values for cos, because cos was easier. So the positive cos, we look for the closest what? What should be on the y-axis for positive cos if it hasn't moved? What particular part of this graph should be on the y-axis if it's a positive cos that hasn't been moved? The maximum. And if it's a negative cos, what needs to be close to the y-axis? The minimum, we agree? So for positive cos to get our c value, we look for the maximum. Wow, the maximum is where? On the y-axis. So that's why I said this one was done, or you could have put a plus 0 if you really wanted to, but it didn't move. It didn't have to move. It was on it. We agree? Now negative cos, I look for the closest what this time? Minimum. So could they pick either one? Yeah. So we said we could have went minus 2 pi or plus 2 pi. We would have went minus 2 pi to go to the right or plus 2 pi to go to the left. We agree? And both would have worked. So I can go x plus 2 pi if I want, or x minus 2 pi, and both would give me the same thing. We agree? Coses and sines were easy. I just looked for where the max and the mins were. We agree? Okay, now, type into your calculator y equals sine x. Type it in. Y equals sine x. And then in your y2, type in 0. And remember I told you you can go over to the slant on the y2 and make sure this is thicker, or 0 won't even show up. You won't even be able to see it. Now make sure your mode is radians. It should be, because that's what we were in before. And then go zoom trig, which is number 7. You should get something drawing in front of your face. Zoom trig. So what you should see in front of your face is something like this. The sine graph will look like this. Like that, right? And then you have a thick line being drawn here. Do you agree? Ah, it's not even too bad of a graph. We'll just imagine those two maxes and mins are the same height. Okay, bear with me. So, what do we notice about the midline? The midline intersecting, because y equals 0 is my midline, we agree? Because sine x has a plus d of 0. So, I know my midline is 0, so that's why I drew my midline here. What can you say about the intersection and the midline when it's increasing? So do you see how it's increasing here? And there's my intersection? Where is that intersection on? It's on the y-axis. Look. Let's pretend. Oh my gosh, it's getting worse. Not better. It's intersecting right on the y-axis. Do you see that? Okay. Now type, go into your y1 and put in negative sine x. Now your midline and the intersection are on the y-axis, but what kind of slope does this line have? A decreasing slope. So if you want to find the c values of sine and not use a lot of brain matter, this will work every single time. You go to your original graphs. We go to this one here. I have my midlines drawn. Do you see them? The midlines are drawn there with the graph. I find the intersection of the midline and the graph, the two closest ones to the y-axis, and I bold them. And then I put an arrow on them. This one's going up, this one's going down. Do you see that? Go do that on your graph. Bold the intersection points with the midline and the graph. And then draw arrows up and arrows down. You're going from left to right. So the first one is an arrow increasing and the second one is an arrow decreasing. We see? You see that? That bolded dotted point is the c value, that x value. So I want the positive sign. Which one of those is the positive sign? The arrow going up or the arrow going down? Arrow going up or arrow going down for positive? Up. So where is this happening at? What x value is this? It was negative pi. We agree? So where did it's supposed to be here? Is it there? It's supposed to be on the y-axis. It's not on the y-axis. It's actually what? Pi to the left. We agree? So how do we do that for positive sign? We go minus, or do we do minus to go to the left? Plus pi. Then we're done. Because it's supposed to be on the y-axis. It's not. It's pi to the left. We agree? Now negative sign uses the decreasing arrow. How far away is it from the y-axis? Pi to the what? Right. So I go minus pi, and I'm done. So the key part of the c value for sine is you need the midline. And then you just do the intersections that are closest to the y-axis. So let's look at the next one. So if I draw the midline of this one, the midline of this one is at 0 again. So here's my midline. The equations you should have below are y equals this one, positive 2 sine, my b was 1 x plus 0, and y equals negative 2 sine 1 x plus 0. We agree those are the two equations sitting at the bottom that we don't have c values for? Okay, I draw my midline. I got it. Then my next step is to bold the intersections that are closest to the y-axis. So this is closest to the y-axis, this intersection, and this one. You see those are the two closest intersections with the midline? Then I draw my arrows from left to right. So this one is going downwards, and this one is going upwards. Let's do the positive sign first. Positive sign first is the increasing one, right? It's supposed to be here. Is it there currently? It's actually what? Yeah, quarter pi to the right. So I need to go a quarter pi to the right for my positive sign. Why am I moving this? So if I want to go a quarter pi to the right, I'm going to minus 0.25 pi. And this one's supposed to be on here. For negative sign, it's the decreasing one, but it's not on there. It's actually how much to the left? Yeah, 3/4 pi to the left. So I'm going to go plus 0.75 pi. Then we're going to flip over. Can we check these equations? Yeah, we can type every single one of them into the y equals and make our window be the exact same as this window, and we should get the same graph, shouldn't we? The only time you won't get the same graph is if you put this window and you have it in degree mode. It'll never happen. What is this actually? Radians. You have to have it in radian mode, make your window match this. Your graph should be the exact same. You should walk away knowing if you're right or should cry. Those are your options. All right. Looking at this one, we're missing two equations. At the bottom, we have y equals positive 2 sine, what was it? 2 pi over 0.67 x plus 0 again. And your midline's at 0. So we draw it. We have to have our midline or we can't get our c value. And then we have y equals negative 2 sine 2 pi over 0.67. So once again, we look for the closest intersections. Here's one. Here's the other. This one's downwards. This one's upwards. This is 0.165. It's halfway to 0.33. Which one is the left or the right one for positive sign? Is the left or the right one for positive sign? The right, because it's the positive slope one. So to get the positive sign, it's supposed to be here, but it moved 0.165 to the right. So I'm going to go minus 0.165. And then this one moved 0.165 to the left. You do all the next ones, see if you can get the c values for sine. Let's just see where we're at. So this one is a bit trickier. You're going to have y equals positive 3 sine. My v is going to be 2 pi divided by 4. So pi over 2. X minus 4. So your midline should be straighter than that, but let's pretend it's straight. And then we have y equals negative 3 sine pi over 2 x minus 4. Okay, closest intersection is here and here. This one's on the way up. This one's on the way down. They should be here. They are not. So this is a positive sign. It moved 1 to the left. So I'm going to have to go plus 1. My negative sign moved 1 to the right. So I'm going to have to go minus 1. So it's literally, if I took from the y-axis, how far do I need to go to get to it? So the midline and the intersections are the most important part. This one, you're going to have y equals positive 3 sine, it's over 4, so it would be pi over 2 again, x plus 0. Minus 0. Okay, so our intersection is at, or our midline, sorry, is at 0. Intersection 1 is here. And then there's this one or this one. So they could pick either or. This one's the downwards one. This is the upwards one. This one is on the y-axis. So my negative sign is done. Or I could go plus 0 if I wanted to. For my positive sign, both of these are equally the same part. So I could go plus 2 or minus 2. Whichever version you picked, you'd actually be correct. Because it moved either way. Because I could move 2 to the right and minus 2. Or I could move 2 to the left and plus 2. It would be the same thing. But the negative sign is on the y-axis. This one. So we have y equals, see this one says a is greater than 0, and then this one says a is less than 0, so these are going to be our signs. So this one would be positive 3 sine, my b is I, so we're going to go to 2, something, and then my d value is 2. Plus 2. This would be y equals negative 3 sine. So this is how they can force it to be a negative or a positive, right? By just putting the a's have to be positive or the a's have to be negative. So I go to my closest intersections. This one is downwards, and it's on the y-axis. So sine's done. So I can go theta and be done. Or I could go plus 0 or minus 0, right? And it would still be correct. They just won't have plus 0 or minus 0. They'll just have theta. And then this one, these are equidistant. But how can I figure out what the heck this is? How many ticks is it to pi? 1, 2, 3, 4, 5, 6. So this is 1 pi over 6, 2 pi over 6. This is 3 pi over 6, 4 pi over 2. Or hopefully you can see that this is halfway to pi, which is pi over 2. So you correlate either of them. But this would be pi over 2 to the right. So I would go theta minus pi over 2. Now the homework I gave you on Friday or Thursday, you weren't here Friday, you were but not here, it's the same homework, because remember I gave you sines and cosines, but then I told you with sine you just leave the c's out because you don't know how to do them. So now you do. So it is going to be I don't remember the page anymore. Anyone have the page down?
Page 253.
Yeah, number 15 and 16. You have 15 minutes. I expect every single person to be working. If you don't have your textbook, look what I have. A textbook. You can take a picture of it for all you need. Okay? So you're doing number 15 and 16, which is why I assigned you on Thursday. But I told you number 15 was sine functions, so you wouldn't be able to do the C letters. But now you can.